Second problem on Cayley Hamilton theorem. If A equal to 2, 1, 1, 0, 1, 0, 1, 1, 2, find the value of matrix A power 8 minus 5A power 7 plus 7A power 6 minus 3A power 5 plus A power 4 minus 5A cube plus 8A square minus 2A plus I. This is very big expression. You have to calculate the value of this total expression by using Cayley Hamilton theorem. This is the application of Cayley Hamilton theorem. Recall the statement of Cayley Hamilton theorem once again. Every square matrix satisfies its characteristic equation, means you should calculate the characteristic equation of given matrix. Now characteristic equation is determinant of A minus lambda I equal to 0. Formula, what is the formula for this one? Lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. Now I am considering directly characteristic equation 2 minus lambda 1, 1, 0, 1 minus lambda 0, 1, 1, 2 minus lambda equal to 0. C1 equal to sum of the principal diagonal elements. 2, 1, 2 are the principal diagonal. C1 equal to 2 plus 1 plus 2 equal to 5. Now minors of 2 plus minor of 1 plus minor of 2, C2 equal to minor of 2, determinant of 1, 0, 1, 2 plus minor of 1, determinant of 2, 1, 1, 2 plus minor of 2, determinant of 2, 1, 0, 1. After calculation 2 plus 3 plus 2 equal to 7. Now C3 equal to determinant of A, that equals to 3 by calculator, scientific calculator. Therefore characteristic equation is lambda cube minus 5 lambda square plus 7 lambda minus 3 equal to 0. By Cayley Hamilton theorem, A cube minus 5A square plus 7A minus 3I equal to 0. Now every square matrix satisfies its characteristic equation. Wherever lambda is there, simply you substitute in place of lambda A. Now last element is, last number is 3 is there. Instead of that one, I am writing here 3I. We are converting that number into matrix minus 3I. Now this is equation number 1. Then we can use that this equation, given expression, you take that expression A power 8 minus 5A power 7 plus 7A power 6 minus 3A power 5 plus A power 4 minus 5A cube plus 8A square minus 2A plus I. Now observe the first 1, 2, 3, 4 terms. Now I am taking A power 5 is common. From A power 8, if you are taking A power 5, then it becomes A cube minus 5A square plus 7A. A power 5 it has gone, means minus 3. Instead of minus 3, we are writing here minus 3I. Now from the next term, plus A is common. Then if you are taking A common, from A power 4, it becomes A cube. From the next term, minus 5A square plus 8A minus 2I. A is common, that minus 2 becomes as minus 2I plus I. Now observe this one, equation number 1. A cube minus 5A square plus 7A minus 3I equal to 0. Means in this bracket I will write 0. A power 5 into 0 is 0 plus A into, now observe this one, A cube minus 5A square plus 7A, I need minus 3I, but minus 2 is available. Now I will add minus I and minus I. Then it becomes minus 3I, and the remaining term is, from the few terms, A power 5 is common. A power 5 into a cube minus 5a square plus 7a minus 3i. A power 8, a power 5 is common means a cube. Here minus 5a square, 7a power 6 means a power 5 has gone, 7a minus 3 only means minus 3 becomes as minus 3i plus from the next few terms I am taking a common. From a power 4 a is common means the remaining term is a cube minus 5a square plus 8a minus 2 means minus 2i plus i. Now from the first equation a power 5 into this total term is 0, right. Now a into I need here a cube minus 5a square plus 7a I need here, but the extra term 8a is available here. Now I will consider only 7a, the remaining term a I will write in the next part, a cube minus 5a square plus 7a minus 2i is available. Then instead of minus 2i I am writing here minus 3i. To balance that one you have to write a square plus a plus i, right. Again a into this term is 0 from the equation 1, the remaining term is a square plus a plus i. Now you calculate this expression from the calculator. A square equals to 5 4 4 0 1 0 4 4 5. Now by using calculator a square plus a plus I, a square matrix you write here, given matrix A plus identity matrix. When you are adding these three matrices, the final answer is 8 5 5 0 3 0 5 5 8. Now this is the value of, this is the matrix of the given expression. Now important problems on Cayley Hamilton theorem. By using Cayley Hamilton theorem you can calculate inverse and powers of the given matrix. Now these are the three important problems on Cayley Hamilton theorem.